Alright, in this video we will review how to identify important characteristics of a graph. For example, domain. Domain represents the x values of a function. It's how far the function goes from left to right. This graph goes to the left forever and it goes to the right forever. So the domain is going to be negative infinity to positive infinity. Alright, which is very common. Negative infinity always comes first. All intervals will be written from least to greatest, so negative infinity to positive infinity. Now, the range is the y values of a graph. So it's how far a graph goes from bottom to top. Now, many of you guys want to give the range from top to bottom, because like when you're reading a book, you read from top down. But that's not the way it works. It has to be from least to greatest. So that means from bottom to top. Now this graph goes down forever and it goes up forever. So again, it's going to be negative infinity to positive infinity. Alright, do not switch it the other way around. Now, absolute maxima. Alright, or if there was one, it would be absolute maximum. Now, the absolute maximum would be the highest point on the graph. But because this graph goes up forever, there is none. Okay, there is no absolute maximum. What about a relative or local maximum? Well, the top of this little hill right here, it's not the highest point of the graph because we have all this over here. But this is the top of its own little area. So, to me, that seems like about a height of, that was supposed to be an eraser. Let's see, this is -2. It looks like about a height of -2.5. Okay, so at the very least, you have to put the y value, which is -2.5. Now, if you want to put the x value as well, alright, we're talking about this point right here. So this looks like about -1.5, -1.5. So you could give me the whole point, -1.5, comma, -2.5. Okay, now absolute minima. There is no absolute minimum because this graph goes down forever. So we'll just put none. What about relative minima? Well, look at this area right here. Whatever this point is on the very bottom, that's going to be a relative or local minimum. Okay, so that reaches a low of about -7.3. So at the very least, you have to give me the y value and say -7.3. Now, if you said something else, okay, like -7.2 or -7.1, I'm still going to give it to you. But don't say -7. That's rounding too much. I see daylight. Or I will accept it if you just give me the entire ordered pair, which is, this is about, let's say, 0.8. So I could say 0.8, comma, -7.3. Alright, zeros. Zeros are the x-intercepts of the graph, just written as a single number. So this right here is the only zero of this function, and it's at 2, so you just put the number 2. Alright, if I said x-intercepts, you would say 2 comma 0, but if I just say zeros, you just put the number 2. Now, y-intercept. Alright, I feel like I was too far away from the graph. The y-intercept, of course, is the place where the graph touches the y-axis. Okay, I'm supposed to have an eraser now. Okay. Okay, so my y-intercept is right here. Alright, so that is the point 0, -6. Alright, now end behavior. As x approaches negative infinity, alright, that's a fancy way of saying what happens on the left. And then it says as x approaches positive infinity. This is a fancy way of asking what happens on the right. Okay, to the function, to what happens to the y values. So as we go to the left, alright, so here we are going to the left, and ultimately we wind up falling. So as we go to the left, the function approaches negative infinity. Alright, on the left, this graph falls. Now on the right, this graph goes up. Okay, so as we go to the right, the function approaches positive infinity. Okay, so that would be the end behavior. Now, intervals of increasing or decreasing. The most important thing, guys, is that these intervals are x values. X values. Last time we had a quiz on this, a bunch of you kept giving me y values. Quit it, all right? These intervals are always x values except for the range. Okay, so increasing and decreasing. If I'm walking along this graph from left to right, part of the time I'll be going uphill, part of the time we'll be going downhill. Okay. So, as I go from left to right, I'm going uphill for this part of the graph. Okay. And then I'm going to be going downhill for this part of the graph. Alright, and then I'm going to be going uphill again for the rest of the graph. Alright, now remembering that we are dealing only in x values, I'm going to go through and put x values on the critical points. Okay, including the arrow here. Now this arrow is pointing down, but I don't care about that. Because it's going to the left, alright, that's the x value of it. So I'm going to call this negative infinity because that's the x value of this arrow. Now the x value of this spot right here, we decided was like negative 1 point, that was a local max. We called it negative 1.5. So I'm going to do that again. Negative 1.5. Okay. Now down here at the minimum, this is about 0.8. So the x value is 0.8. Okay, of this spot right here. And finally, this arrow up here, the x value is infinity. Not because it's going up, but because it's going to the right. That's the x value part of it. Okay? So, the first increasing part of my graph goes from negative infinity to negative 1.5. See, just x values. Negative infinity to negative 1.5. Alright, these increasing and decreasing intervals always get round parentheses because right at the change point it's neither increasing nor decreasing. Now we have another increasing interval, okay, this keeps erasing, from 0.8 to positive infinity. So I'm going to say union and say 0.8 to positive infinity. Alright, now we had one decreasing interval right here from negative 1.5 to 0.8. Okay, that's my one decreasing interval. Alright, so that was it for number 14. Alright, now it's time to take a look at number 15. Okay, and they helped us out by giving me some of these values. Okay, that'll make it easier. Alright, the domain. The domain is the x values of the graph. Like many graphs do, this graph goes left forever and right forever. So the domain, once again, is going to be negative infinity to positive infinity. Okay, I don't know why it's not showing up. Now the range is the y values of a function. So for the range, we're looking at how far does this graph go from bottom to top. Alright, in that order. Not top to bottom, bottom to top. Now this graph goes down forever. Okay, even though I didn't draw arrows on here, it still means down forever. So that's negative infinity down here. Now how high does it go? It doesn't go up forever. It goes as high as this y value right here. This is the y value. So it goes up to 4.7. So the range is from negative infinity to 4.7. Okay, and I will use a square bracket to include the 4.7. Alright, this graph touches 4.7. Okay, now absolute maximum would mean the highest point on this graph. Does this graph have a highest point? Yeah, it's right here. This is the highest point on the entire graph, 4.4, 4.7. Okay, now you could just put the y value if you wanted to. What about local or relative maxima? Okay, so this spot right here is the top of its little hill. Even though it's not the highest point on the graph, because it's the top of this little hill, it is a local maximum. So that is negative 6, 0. Alright, or you could just put 0 if you wanted to. Absolute minimum, there is none. This graph goes down forever, so there is no absolute minimum. So I'm just going to write none. What about relative minimum, relative minima? Okay, see the bottom of this little hill right here? This is a relative minimum. It's not the absolute minimum because the graph goes lower than this, but it's the bottom of this little valley. So negative 1.4, negative 6. Okay, so this is an ordered pair. If you want, for this, you could just put negative 6. Alright, now the zeros. The zeros are like the x-intercept, except we're just going to put numbers. There are 3 of them. Okay, there's a 0 here, there's another one here, and then there's another one there. 3 x-intercepts, so negative 6, 2, and positive 6. Okay, the y-intercept, so where does it touch the y-axis? It touches the y-axis right here at the point 0, comma, -5. That's the y-intercept. In behavior, all right, as x approaches negative infinity, that means the left. Okay, and they're asking what happens to the function. So on the left, this graph falls. Okay, so as we go to the left, the function ends up falling. So that's negative infinity. All right, so as x approaches negative infinity, as we go to the left, the function approaches negative infinity. It falls. What about as we go to the right, which is what this means? As we go to the right, the graph also falls. So that'll be another negative infinity. All right, falls, falls. Falls on the left, falls on the right. Okay. Now, once again, intervals of increasing and decreasing. All right, and once again, the most important thing for me to emphasize to you guys is we're only dealing with x values, not y values. Okay, so I'm going to go through and put x values on everything. Oh, first of all, the rising and falling. If I were walking this graph from left to right, for this part of the graph, I would be going uphill. All right, so this, I'm increasing, 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 increasing until right there. And then for the next little while, I shall be going downhill. So this pink part of the graph is decreasing. Down, 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 down. Okay, and then I'm going to turn around and start increasing again. Okay, I ran out of space. Okay, so I'll be increasing again. And then over here, I will start decreasing again. Falling, 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 falling. Okay, and this is also decreasing. The computer just erased it for some reason. I don't know why. So the green areas I was going uphill, the pink areas I was going downhill, increasing and then decreasing. So right now I do believe we were supposed to be working on intervals of increasing. So the green ones. Okay, now let's go through and put x values on everything first. So on this end over here, see how this is going downhill? Sorry, I don't care about the fact that it's going downhill. This is on the left. So because this is on the left, I'm going to call this arrow negative infinity because I'm doing x values, left, right, not up, down. So left is negative infinity. The x value right here is going to be -6. All right, the x value right here is going to be -1.4. All right now I don't care about the fact that it's -6. All I want is the x value. Same thing up here. The x value is 4.4. I don't care about the 4.7 right now. We're doing all x values. And over here on the right, this is going to be a positive infinity. All right, you're going to be tempted to put negative infinity because it's pointing down. But we are doing x values. Okay, left is negative infinity, right is positive infinity. That's how x values work. Okay, I need to make this a tad smaller. Okay, so my first increasing interval is going to go from negative infinity to -6. All right, not 0, -6. We're doing x values. So intervals of increasing, negative infinity to -6. The other increasing interval shown here in green goes from -1.4 to 4.4. All right, increasing and decreasing intervals are always shown with parentheses, not square brackets. No square brackets, because right at the borderline, it's neither increasing nor decreasing. It's right in between. Okay, now let's talk about the decreasing intervals. Decreasing intervals are shown here in pink. So I've got one going from -6 to -1.4, strictly x values. -6 to -1.4. And there's another one coming, so I'll put a union. And then the other decreasing interval is shown here in pink, from 4.4 to positive infinity. Not negative infinity, positive infinity, because it's to the right. Negative infinity is to the left. So 4.4 to positive infinity.